All right, so for question 3, I'm assured that the first answer that was, or the first question that was asked over here, many weird and wonderful answers were given. Benzoic acid is just the benzene ring, all right, with a carboxylic acid group onto it like that. That's all it is. If you didn't answer that, you didn't get your mark. All right, it's one of those things you're just going to have to learn and we expect you to know. All right, okay, so this question a little bit more tricky because we've got a Z double bond that we need to incorporate. But let's not worry about that first. First of all we need to do is just sketch out the parent chain, which is a hex, so it's 6 carbons. I'm just going to do this lightly because 1, 2, 3, 4, 5, 6, because we may have to erase something and write it out neater afterwards. So it's 6 carbons, it's an one, so that means there's a ketone, and it's on position 3. 1, 2, 3. All right, and there's a double bond on position 4, all right, and then there are methyl groups on positions 2, 2, and 4, so 2, 2, and on position 4 over there. All right, and we're told that this has to be the Z double bond, so Z means it needs to be on the same side. And so if we look at the priorities over here, on this side of the double bond, this is the higher priority side, and on this side of the double bond, this must have the higher priority. So they're actually, if I wanted to draw like a little line through it, these are on opposite sides over there, and because of that, that's actually the E that I've drawn. So what I have to do is actually have to switch it around and make this one into an H. Now the 2 higher priorities will be on the same side, and this will be the Z one. Now, when you're working it out, it's actually a good idea to do all this working out somewhere else, all right, which you can erase. Do everything in pencil, it's fine, and then redraw it out very neatly, because in your answer, we don't want to see you with, drawing out the little dashed lines as you sort of trying to work out whether it's E or Z or anything like that. All I want you to give me the final answer neatly written out without any other bits and pieces on that. So if we draw it out neatly at the end, we're going to get it looking something like that. All right. Okay, S-pentane 2-thiol. This is just a very basic one, but the difficulty was getting the chiral center correct. There are a number of different ways you could have drawn it out. Let's just draw out the pentane. All right, 5 carbons. And then it's a thiol. Thiol is an SH, all right? So it's an SH group on carbon number 2. So just draw it in lightly. We're going to have an SH over there. The question is this SH pointing up or is it pointing down? So we just assign it. We'll just pretend that it's pointing up, okay, for argument's sake, and we assign the chirality. So if it was pointing up, this would be carbon 1, this would be carbon 2, this would be carbon 3. Right? Okay, I've made that very light, but let me make it a bit darker. See that? 1, 2, 3, and we're going round towards the right. Okay, so if we're going round towards the right, if this is pointing up, then we're looking, it's wrong. This is the R configuration, and we want the S. So all we need to do is, instead of this pointing up, we just make it pointing down. If we're not sure, let's test it again. 1, 2, 3, we're going round to the right, but we're looking at it back to front because the H is pointing up. So if the H is pointing up and we're going round to the right, it looks like it's R, it's actually S. And this is the correct answer. Now, of course, you may have drawn this in a whole host of different ways, and it doesn't matter so long as you drew it out correctly. For instance, this one over here would also have been correct. Maybe you zagged instead of zigged, and in which case an SH over there would have been correct. So there are a lot of different ways that this could have been drawn out, all right? You would have got the marks if you'd done it correctly, but the process that I showed you over there is what you needed to do. Again, when you do the answer, just get rid of all your little working out bits and leave it nice and neatly. And then this last question here on 3.4, apparently it was some very strange things also happened over here, especially with the cyclopropyl. Remember, cyclopropyl is 3 carbons, so it looks like something like that. Okay, so it's a hexanoic acid, so we've got, I just wanted to see that you could do this properly, 1, 2, 3, 4, 5, 6, and it's an acid, so it has to look like that. So that's hexanoic acid. But there's a phenyl group on carbon 4. That's carbon 1. So 1, 2, 3, 4, and we have a phenol group, which we could write as pH, or you could have drawn in the benzene ring. That would have been fine as well. Okay, and then on position 3, we have a cyclopropyl ring. So this ring must go on over here. And apparently some people were giving the answer that looked like this. It's kind of like a little bit of a Christmas tree. All right, it's not Christmas yet. This shows a bond going to the middle of a bond. There's no carbon over there. That suddenly changes things. So this was wrong. The cyclopropyl ring, what you need to do is put it something like that over there. All right, so that was question number 3.